Hi guys, my name is Fanu and I'm going to be your instructor for Calculus 1 this semester. In this video, I'm going to explain to you what calculus basically is and the various applications it holds. Calculus, ladies and gentlemen, is the study of change. As compared to the other fields that we've studied so far, algebra being one of them and geometry being another, these fields talk about, in algebra basically, you talk about different variables and how we can manipulate them to form different equations, right? In geometry, we take different shapes, try to describe the relation of these shapes with respect to other shapes, and at the same time, we also try to determine different forms and different rules for the set of all shapes that are out there, right? Calculus basically takes these two fields and incorporates the elements of these two individual fields and comes up with a field of its own in which we talk about the rate of change. The rate of change of various variables such as x, y, and other examples, of course. Now I'm going to be talking about the various applications that we have seen in our daily life that include the concept of calculus being applied to it to great extents. Everybody's played snooker, right? In snooker, we basically have billiard balls moving towards each other with a particular speed, v, which might not be the same as the speed of this particular ball, which could be v2. We can use calculus to determine what's going to happen when these two balls collide, and what's going to happen to this ball after the collision takes place, and consequently what's going to happen to this ball. This is used to determine the result of this particular state after a particular time. So this has to be at time 0, and that could be at time 1 after the collision has taken place. So at this point, we need to figure out if this is going to recoil with a velocity v1 prime, and what's going to happen to this ball. It may also recoil with a velocity v2. So that basically depends on the particular situation. So calculus would be used as a model, as a mathematical model to be able to describe these situations. Another example, in this case, would be a cylinder. We have a cylinder. It's closed, and it contains various air molecules that are colliding with each other and are basically interacting with each other, and they have a particular speed, a particular pressure, and at the same time we're trying to heat this using a Bunsen burner maybe, right? And we're increasing the temperature of this cylinder right over here. If this temperature and if the temperature and pressure of this cylinder is T0 and P0 at a particular time, what's going to happen to this cylinder with respect to time? Over, like, I don't know, after like a couple of hours maybe, what's going to be the temperature of the particles? How will the particles be interacting with each other? All of this will be achieved using a calculus-based model that's going to tell you what's going to happen after that particular time. Another example that you guys may have heard of is related to stock exchange. If somebody calls you and tells you that there is an option available on the London Stock Exchange or the Lahore Stock Exchange for that matter, and that it would be sufficient for you to buy that stock and it would be profitable for you, what would you do in that case? So basically, if you're a mathematician, if you know calculus, you'll be using a particular mathematical model to be able to assess the worth of this particular stock with respect to time. So I'm going to use this model to try to determine what the value of this the value of this particular stock was at any particular point in time, right? We could say like what's been happening to the price since the past 4 months maybe, and using that data we can predict the future, which is another awesome application of calculus, being able to predict the future. Now, how accurate that is actually depends on how good of a mathematician you are and how good you're able to use calculus to make the connections. And if you're able to do this successfully, then we can assess that this stock is probably going to be profitable to me and that I should buy this because in the past 4 months its cost or its price has been increasing exponentially. all that's happening over here is the application of a mathematical model that's been built upon by principles of calculus that you will be later studying in this course. Another example of calculus-based mathematical models would be the aircraft company Boeing. Initially, Boeing had a very different approach to building aircrafts. It had a wind tunnel, which it still does. This is an aircraft that Boeing made back in the 80s that's passing through the air tunnel they constructed. And it has a particular element that has a particular dimension. The wing is XYZ length long. It has these dimensions that are going to be used in the calculation. What Boeing did back then was use these dimensions and make a model and make it pass through the air tunnel. And if it turned out to be advantageous to them, efficient to them, they'd compare it to other models that they'd construct and make them pass through the air tunnel. And they'd compare the different models. The problem with this approach was it was cost intensive. And this is something that cost them a lot. And they wanted to come up with a cost efficient method. So they made a mathematical model, a software actually, that used a model that used different characteristics that took different values of X, Y, and Z for the size of the wing or the size of the aircraft's body and compared the different models obtained. Those shortlisted models were then compared and passed through the air tunnel for comparison. And the best model would emerge. Now, if you think about it, this is a very cost-efficient method that's been achieved using calculus. Another example of a calculus-based model is for the biologists out there. It's regarding the lung tumor problem. Now, in order to remove the tumor from the lungs, there has to be an antidote gas that has to be inhaled by anyone who has contracted this disease, right? So the problem here exists in the testing stage of this antidote. And we would need participants who would inhale this gas and different proportions of this gas that might as well be in a large amount. And we don't know what this gas contains, but it could be, if it is inhaled in large amounts, then it could prove to be lethal to a certain extent to the person who is inhaling these, right? Considering this particular situation, out of all the people who are watching this video, if I were to ask you to volunteer for such an experiment, you would not say yes to this. I'm pretty sure about that. And the problem is that we don't really know the effects of this gas that's inhaled by the people who are infected with this, right? We don't know what it's going to do if it's inhaled in large amounts. So what we do instead is we come up with a mathematical model and we discover the effects of this gas on the particular lung tumor that resides in the lung of a particular person, and we try to determine what's going to happen when these particles, gas is basically made of particles, right? So when these particles deposit on the lung, what's going to happen and how this change is related to the infection in the lungs or the tumor that's found in the lungs, right? So calculus is used to achieve that, and it may as well solve a lot of problems that would otherwise be problematic for the community, right? So finding people who are actually volunteering for such experiments that could prove to be lethal to a certain extent, can be a problem. Another example in this regard would be of hypothermia. It's basically a therapy in which cancer cells are exposed to large temperatures, due to which the cancer cells die. But finding participants who are willing to offer themselves up for treatment in this case is also problematic. So what we need to determine is if the normal cells are affected by this activity as well. And in order to do that, we're going to have to test it out. But instead of doing that, instead of going for something risky, we make another mathematical model and we use it to describe the relation between the normal and the cancerous cells. And what's going to happen if we provide heat to these cells? Will these be affected as well? So this is all going to be based on calculus. In the next video, I'm going to be talking about the different topics you guys will be studying in this course, and from then on we'll proceed to the different concepts that you will have to use in order to make all these connections to the various daily life situations that we encounter.